Hello ladies and gentlemen. Today's video is about decimal representation of rational and irrational numbers. First, we talk about a decimal representation of rational numbers and then irrational numbers. So basically, rational numbers has two types of decimal representations. The first one is terminating decimal and the second one is recurring decimal. So let's first talk about terminating decimal and then recurring decimal. We can define a terminating decimal in a simple words. A decimal which has a finite number of digits in a decimal part is called terminating decimal. As we have already know about finite and infinite numbers, let's have a quick look on both type of numbers. For finite numbers, we can say the numbers that are countable are called finite numbers. For example, the first 10 numbers of a natural set are finite numbers. And for infinite numbers, the numbers that are not countable are called infinite numbers. For example, a set of natural numbers is infinite. So this is all about finite and infinite numbers. Let's take some examples to better understand the terminating decimal. First of all, let we have a rational number 5 by 2, whose decimal representation is 2.5. Now it is clearly visible that there is only one digit in a decimal part and that is 5. So this is the terminating decimal. Finite number of digits in a decimal part is called terminating decimal. One more thing to know, that it is not necessary that there should be only one digit in a decimal part to be terminating decimal. Actually, there could be more than one digit. But there is a restriction that those digits should be countable. For example, let we have a rational number 855 by 16, whose decimal representation is equal to 53.4375. Now we can see that there are at least 4 digits in a decimal part and these are finite number. So this is also a terminating decimal. So this is all about terminating decimal. Now we will talk about recurring decimal. Basically, recurring decimal is also called periodic decimal, and for the definition of recurring decimal, we can simply say that a decimal in which there is a repetition of one or more digits indefinitely in a decimal part is called recurring decimal. Indefinitely means which has no exact limits, means which is beyond the limit, which is infinite. So let's take some examples to better understand the definition of recurring decimal. First of all, let we have a rational number 2 by 3. We know that the decimal representation of this number is equal to 0.666 and so on. So we can see here that there is a repetition of one digit 6, that is 6 in this case, indefinitely for an infinite time in a decimal part. This is in the decimal part. So this is the recurring decimal. Also you need to know that it is not necessary that there should be only one digit repeats itself for infinite time to be a recurring decimal. Means there could be more than one digit that repeats itself for infinite time. For example, let we have a rational number 7 by 13 whose decimal representation is equal to 0.53846. Now you can see that there are 5 digits that are repeating itself in a decimal part for infinite time. So this is also recurring decimal. Now let's take final example of recurring decimal. Let we have rational number 7 by 15 whose decimal representation is equal to 0.4666 and so on. Now you can examine here that there are 2 digits in a decimal part. One digit exists only once and the other digit, that is 6, is repeating itself for infinite time, is repeating itself indefinitely, which has no limits. So that is also a recurring decimal. And you also notice a bar on digit 6 here on digits 5, 3, 8, 4, 6 here and on digit 6 here. This bar on any digit means that this digit is repeating for infinite time. So guys, this is all about decimal representation of rational numbers. Now we will talk about a decimal representation of irrational numbers. Basically, irrational numbers has only one type of decimal representation, and that is called non-terminating, non-recurring decimal. Regarding the definition of non-terminating, non-recurring decimal, we say a decimal which has infinite number of digits in its decimal part and also there is no specific pattern of repetition is called non-terminating, non-recurring decimal. So from the definition of decimal representation of irrational numbers, we can also say that decimal representation of irrational number is opposite to the decimal representation of rational numbers. Yes, it is true. We can say that. Now let's take some examples of decimal representation of irrational number, means some examples of non-terminating, non-recurring decimal. First of all, let we have a number 89 by 76. From this number, we can see that this number is fulfilling both conditions of rational number, that both values in the numerator and denominator should be the members of integers and the value in the denominator should not equal to 0. It should be a rational number? Yes, it should be, but it is not. Why? Because we can see that this number has a decimal representation which has infinite number of digits and also there is no repetition of digits, means there are random digits. So that's why this number represents the non-terminating, non-recurring decimal, infinite number of digits and no specific pattern of repetition. Therefore, this number is an irrational number. Similar to this number, let we have another number 816 by 95. So this number is also fulfilling both conditions of rational numbers, but it is not a rational number. Why? Because this number has a decimal representation which has infinite number of digits and there is no specific pattern of repetition. So this number also represents non-terminating, non-recurring decimal. Therefore, it is an irrational number. Let's talk about root 2. We are familiar with this number and we are also familiar that this number is an irrational number, but why? So the reason is this number has a decimal representation 1.414, 135 and so on. You can see there are finite number of digits in its decimal part and no digit is repeating. So this is the reason that this number is an irrational number. So we can also say that any number that has a non-terminating, non-recurring decimal representation is an irrational number. Yes, it is true. So I would like to remember you one thing. In my previous video, I said that I will tell you why pi is an irrational number. So let's talk about this. Basically, pi is approximately equal to 22 by 7 and we can see that both numbers are integers 22 and 7 and this fraction is fulfilling the condition of rational number, but this is not rational number because similar to this number pi has also the decimal representation which is non-terminating and non-recurring, so therefore pi is also an irrational number. Similar to pi, Euler's number represented by E and the golden ratio represented by phi has the non-terminating and non-recurring decimal representation. Therefore, these all numbers are irrational numbers because they have non-terminating and non-recurring decimal. So guys, this is all about a decimal representation of rational and irrational numbers. At the end of this lecture, I would like to remind you one thing. In my previous video, I made a statement that square root of any number that is not perfect square is an irrational number. But right now, I would like to make a more specific statement about prime number. I would like to say that Square root of every prime number is an irrational number. But how we can prove this statement, I will tell you in my next video.